Hello, so we are back, and this time we have a customer job. This is a nice laptop, yeah? I don't think I had before i7 12 Gen laptop. 12 Gen i7 and RTX Studio. This is expensive, yeah? This is a Asus Vivobook. Now the problem with this one, look at the keyboard, you know how nice it is? Like, huh. The problem with this one is that the laptop was damaged by water damage. Yeah, no screws on the back. And the customer is saying, this is a water damaged laptop. No power on, I have cleaned the motherboard. I found two spots where I have resolder caps. They are on the back of the motherboard. I marked them for you. I have no messed up with the motherboard on any way apart from resoldering the two market components. It would be great if you could make a video this time, YouTube video this time. Kind regards, Michael. 1 second. Oh yeah. Okay, yeah. Yes. This customer sent me first a Asus X390U. Yeah, and I could not fix it. I sent him a picture. 1 second. I think I can show you. Yeah, yeah. I can show you the picture. I sent him the picture. You know what? The CPU is getting short in one corner. It's nothing what I can do. Yes. Okay, so yeah, some people request videos from the repairs, and I have no problem with that. This has no screws. I remember I had a job like this. You remember? It was the same Asus Vivobook, and if I remember, was a shorted MOSFET here somewhere or here. Yeah. So this is a liquid damage. Let's take the board out, and first let's have a look at the motherboard. Okay, so we took out the motherboard. Let's leave the laptop on one side. Now, the problem is when someone is trying to fix a water damaged board. So most likely, yeah, the customer marked the capacitor. So most likely they clean it. And there's no way to figure it out where actually the fault, the water came onto the motherboard. Because if it's under a chip like this, yeah, the IO chip, how can I know? But interesting, look how the customer marked the capacitors. Water damage there. Okay, so he said was water damage there. Cleaner resolder. This cap wasn't soldered properly. Look, knock off. Okay, that's that's actually helpful. If only here was water damage. Let's have a look together. Let's take this out. I seen it now. So that capacitor, okay. Let's check to see if it's any short there. That's important. So here is no short, we are fine. Okay. What about here? This one. I don't think that it's a capacitor. I think that was a resistor and it's no solder. Cleaner is solder. Oh, okay. I can see the resistor. That, oh, but it's still rusty. Looks resoldered. I mean, looks good, right? Looks dodgy. Okay, it's just a bypassing resistor. It's 1 ohm. And this one? This one, nothing. But this one has 1 ohm. Okay, so it's fine. Yeah, we can see here some liquid damage. And it's 2.7 ohms. Oh, lol. Those are 0.5. 2.6 ohms. Huh. Okay, let's check with the ground. And with the ground is not short. Okay, that's fine. Yeah, it's fine. Nothing wrong there. Good. So I will say, you know what I will say? Let's check if the main power rail is shorted. The main power rail is 0.07 ohms. That's crazy. So this is not a MOSFET, right? So you see on those capacitors, you have the MOSFETs and then you have the capacitors. 0.06 ohms. So this customer can be lucky. Can be lucky. Huh. Okay, let me grab the thermal camera because that's easy. That must be easy. I didn't expect it. I mean, this is the simplest fault, like a shorted capacitor. Okay, let's take the power supply 1 volt. We still have 1 volt from the last video. You remember the video with how you can find a shorted MOSFET? But here is not a shorted MOSFET because the resistance is very low. You can have a shorted MOSFET with a shorted CPU, but not sure what I can say here. Okay, so same like on the video. What do we have on the capacitor? Here we have 1 volt, and here we have 0. Okay, so here is ground clearly because the voltage gets dropped to ground. But here is taking 1.5 amps. 1.5 amps. I have a feeling this customer is lucky. What is there? You can see there is something bright. And it's a MOSFET. Really? Wait, the coils? Yeah, that's a MOSFET. Don't tell me it's going to the CPU. No, this is from the GPU. That's a MOSFET. Huh? The middle MOSFET. Oh, wait. Oh, that's bad. That's bad. So actually the GPU MOSFET is shorted, and then it's normal to have this low resistance. It can give you like can make you believe actually it's a capacitor. So on the coil we have 0.06. You can see. So this MOSFET is gone. Let's remove the MOSFET. Okay, that's bad. So this is the MOSFET. Let's use a little bit of flux. Just a little bit. Good. Hot air. About 480 degrees Celsius. Okay, so we remove the MOSFET. Now the question is, do we still have a short? No, there's no short, you can see. No short. Not sure if I have this MOSFET. 1 second, give me 1 second. Not sure if I have this one. Or, 1 second. Microscope. No, it's not this one. No, it's not this one. It's not this one. This one, yeah. It's something else, but should work. Yeah, that's the one. Yeah, this is our MOSFET. Let's solder the MOSFET back. Hopefully the MOSFET is good. 1 second, because I have a lot of bad MOSFETs around here. Good. It's shorted. That's sick. That's crazy. I have a MOSFET and it's shorted. 1 second. I think I have another one. Yeah, I have another one. 1 second. Good. It's shorted. It's shorted. Oh, that's crazy. And I don't have another one. Yeah, I do have another one. 1 second. 1 second. I do have another one. Good. Good. You know what? This very possible to be good. Let's clean it a little bit. Perfect. What do you think? Perfect or not? Now let's solder the MOSFET. Okay, the MOSFET is soldered on place. Now, indeed, yeah, you cannot mix up the MOSFETs. When you have MOSFETs on the parallel mode, you cannot mix them up. Because if they are not the same, but by the way, the MOSFETs are never the same, but let's say, okay, same serial number, same model number, they are not working the same. And I understand that. I can do order the original part, which I'm pretty sure it will not work the same. That's the reason why one MOSFET is getting shorter from like 3 old parallel mode. Let's say are not parallel mode, are 3 different power supply. You have 3 coils with 3 MOSFETs. Then the coils here are together, indeed. So are three different power supplies. But the way how you can check, and it's very simple to check how the MOSFETs are working. When the laptop is running, you look with the thermal camera, and if any MOSFET is getting hotter compared with the other, it means it's working harder. So that's very simple to test. Okay, still hot. Hit the screen ribbon cable. I believe we are fine. We are ready to test, yeah? Let's connect the power button. Now you're ready for testing. I will check with the power supply and not with the laptop power supply, just to be sure nothing can go wrong. Yeah, and the laptop is coming on. 1.7 amps. And we have picture. We have picture. This is actually a lucky customer. Ha ha. Okay. We connect every cable. Let's plug the charger. Plug in the charger. Let's see. We do have the charging light. Let's wait for the picture. Probably the laptop is on. Yeah, probably, yeah. We have picture on the screen. Fantastic. We don't have the hard drive, so I cannot test it further. But the mousepad is working. The keyboard. Yeah, the keyboard, it is working. Good. Now let's see my power supplies, my MOSFETs and everything. Let's see how they are working. Because the MOSFET which I replace can be working harder compared with the other, or can be lazy. And I believe my MOSFET is working harder. You can't see. My MOSFET is working harder. You can see it? Not sure if you can see it. I mean, it's brighter compared with the others, you can see. So my MOSFET is working harder. So what I will do, I will stop this laptop right now, because the laptop is fine, and I will order the original MOSFET. Usually, if I see all three MOSFETs, or whatever, you have two MOSFETs in a parallel mode, they are working the same, based on the heat signature, yeah? It's okay, it's fine. But when you see something like that, and you cannot see it properly on this camera, but I can see it on the thermal camera, I can clearly see my MOSFET. It's not hot, don't get me wrong, it's not hot, probably around 40 degrees. My MOSFET is working harder compared with the other ones. Yeah, don't forget, those power supply are three different power supplies, all generating same voltage, and the voltage is getting met here, yeah? So those are soldered together, the coils, yeah? Okay, that's fine. This is a lucky customer. Again, I'm happy I helped him this time, because the last time he had that faulty CPU on the board. I will order the MOSFET and I'll replace it. But I believe this job is done. I mean, it was only a shorted MOSFET. That's all. Yeah. Okay. So I will say thank you for watching. Like and subscribe if you like the video, and keep in mind, because I didn't have this tip on any of my other video. When you are replacing, yeah, again, let me repeat myself, yeah. If you are replacing a MOSFET, check how it's working. It's same in like where? I mean, same on like if you work audio amplifier, and on audio amplifiers you have a lot of transistors on the parallel mode, And you have balanced resistors on every transistor, but still you can see a difference. Yeah. So see you on the next one. Bye.